Okay guys, so today we are looking at the third part of section 6.6. These are going to have some more challenging problems to them than the ones we have been looking at. If you look at this first problem, we've got 3 to the 2x minus 2, 3 to the x minus 15 equals 0. This is actually a quadratic function in disguise. I can choose another variable. Let's just choose y. If I let y equal 3 to the x, well, now this problem could become, I can think of this 3 to the 2x, that's really 3 to the x squared. So this is our problem. And if I'm letting y be 3 to the x, then right here I'm going to have y squared minus 2y minus 15 equals 0. The reason I knew to do this is because I could tell that this was actually a quadratic. So now I can factor this. So I get y minus 5, y plus 3, y equals 5, y equals negative 3. But that's not truly what I'm solving for. I'm solving for x. So I have to replace my y with 3 to the x equals 5 and 3 to the x equals negative 3. Well, this is impossible. If I raise a number to a power, it's always going to be positive. So this can't have a solution. But this would just be log base 3 of 5 equals x. And that would be our solution to that problem. We can get the decimal approximation if we'd like. On this problem, notice how we have logs on each side, but this has a base of 2 and this has a base of 4. So I'm going to need to rewrite this so that it has the same base. Here's how I can do it. I've got log base 2 of x. This is log base 2 of 8x over log base 2 of 4. Remember, I can make the base whatever I want to make it with that change of base formula. So now I've got log base 2 of x equals log base 2 of 4. I can figure out 2 to the what's 4. So that answer is just 2. And then in the top I've got log base 2 of 8x. Well, now I can multiply, cross multiply this side by 2, this side by 2. So now I've got 2 log base 2 of x equals log base 2 of 8x. Well, anytime I have a coefficient, I can make it an exponent. So log base 2 of x squared equals log base 2 of 8x. Well, I finally have log base 2 and log base 2. So therefore, x squared would have to equal 8x. So x squared minus 8x has to be 0. Factor out an x. So x has to be 0 or x has to be 8. I'm going to see which one makes sense. Well, way back here at the beginning, x must be greater than 0 on both of these. Well, it's not allowed to equal 0, so my only solution then is going to be x equals 8. And we can see if that works. 8 times 8 is 64. 4 to the third is 64. 2 to the what's 6 is 8. If I plug that in, that's 3. So those would be equal to one another because they would each be 3. On number 3, here's another kind of problem where I don't have like 81, and this needs to be a 3. So what I'm going to do is I'm going to rewrite 81 as 3 to the 4th, and then I have log base 3 of 2. All right, well, at this point, if I have a log, I'm allowed to make this coefficient an exponent. So now I have 3 to the log base 3 of 2 to the 4th. Well, now I have 3 to the log base 3, 2 to the 4th, 16. Finally, I have this in that form where, back up here at the very beginning, if I have log base b of b to the x, or if I have b to the log base b of x, this answer is just going to be x. That's the situation I'm looking at here. So this answer just has to be 16. Similar kind of problem, but this has a base of 2. I want this to have a base of 2. So this is going to be 2 to the third, and then I still have log base 2 of 5. Coefficients become exponents. I have 2 to the log base 2 of 125. 125 is going to be our answer to that. All right, on the next one, okay. On this one, this is a very difficult problem because I have exponents on each side. So I know I have to take the log of both sides, but I can't do log base 5 on this side and then log base 3 on this side. So I just have to make a choice. I'm going to do log base 5. So I'm going to do log base 5 of 5 to the x minus 1. If I do log base 5 of this side, I must do log base 5 of this side. All right, so whenever I have exponents, they become coefficients. So I'm going to have x minus 1 times, well, log base 5 of 5 is 1. Over here, this is going to become a coefficient, and log base 5 of 3. All right, well, I'm trying to solve for x, which means that I'm going to have to get my x's together. This is going to be a little bit difficult. So what I'm going to do is I'm going to distribute this through. So now I'm going to have 2x log base 5 of 3 plus 3 log base 5 of 3 equals x minus 1. In order to solve for x, I have to have the x's on the same side. So this term has an x in it, and this term has an x in it. So the 1 is going to need to go over there, but I'm going to have to subtract this over here. So now I'm going to have x minus 2x log base 5 of 3 equals 3 log base 5 of 3 plus 1, because I added that 1 to both sides. At this point, I'm trying to solve for x. I've got an x here and an x here. So each of these terms has an x in it. I can't subtract them because they're not like terms, but I can factor out an x. So now to get x by itself, I have to divide by all of this. And that would be my answer then. This right here would be my exact answer. Now, if we need an approximation for that exact answer, that's going to take a calculator. And you got to be careful with your parentheses. So I'm going to have to do parentheses, and I'm going to have to go to my log, parentheses, I'm going to have to go to math, log base. I want a 3. I can actually move this 3 up here, though. I'm going to do that to make it easier to type in. So I can type this in as log base 5 of 27, get out of that, plus 1. So I need that whole thing to get divided by 1 minus, I need parentheses, the quantity, 1 minus 2, go to math, log base 5 of 3. Checking that. I need this whole thing, okay, to get divided by this whole thing. Okay, looks good. Negative 8.34. I'll round to the nearest thousandths. And so that should be the correct answer for x. Now, let's say this is a test. It's on the calculator part. Just to remind you that you can check things like this on the calculator, which is so handy. And a problem like this actually probably would be on the calculator part, unless I asked for the exact answer. But if I graph these, I would now want to find the point of intersection, because I want to know where does this function equal that function. And it's really hard to tell where that happens, but somewhere down here. So second trace calculate, I'm still thinking. Second trace calculate, intersect. And we think it's negative 8 something, so we're going to go down this way and just do an enter, enter, enter. And there it is, negative 8.345, so we were correct. All right, on this one, checking out to see if we have the same bases. We do not. But this is something we should know. This is 5 to the what is 1. 5 to the what is 1. That's going to be 0. So now we have log base 2 of 3x minus 4. At this point, I can rewrite it. 2 to the 0 equals this. I'll do it the harder way, though, which is the more mathematical way. Exponentiate both sides with the base. So this is going to be 2 to the log base 2 of 3x minus 4 equals 2 to the 0. So if I do this, my 2's cancel. I get 3x minus 4 equals 2 to the 0 is 1. 3x equals 5, and x is going to be 5/3. All right. These last part, this is just a review of exponents. So I've got 3 divided by 4 to the negative 2. 3 divided by 4 to the negative 2. That's going to be 4 divided by 3 to the positive 2, and so that's 16/9. These are not equations. It's just a review of some exponent rules. Look at the difference. This one is the whole thing to the negative 2. This is just the 4 to the negative 2. So this is going to be 3 divided by, and then 4 to the negative 2 is 1/16. If I'm dividing by a fraction, you have to multiply by the reciprocal. That's going to be 48. Okay, some more challenging ones. This is going to be 9 to the negative 1/2 and x to the negative 3 to the negative 1/2. Write it out. So 9 to the negative 1/2, 1/2 power means the square root. So the square root of 9 is 3. 3 to the negative 1 is 1/3. So if I have 1/3 of 3, those are going to cancel. When my bases are alike, I add the exponents. So all of this is just going to be x squared. This one, 5 and the x to the negative 4, are both to the 1/4 power. So I've got 5 to the 1/4, x to the negative 1, divided by 5 to the negative 3/4, and x to the negative 1/3. Take it one step at a time. This is going to be 5 to the 1/4 over x, divided by, this is going to be 1 over 5 to the 3/4 and x cubed. See, to make these exponents positive, they have to go to the denominator. So all we'd have left here is a 1. So now if I have division, I have to multiply by the reciprocal. Okay? And so now if I have 5 to the 1/4, 5 to the 3/4, bases alike, add the exponents, that's 5. And then I have x cubed divided by x, and that's x squared. So that all simplifies down to 5x squared. All right. Hopefully that didn't go too quickly. If so, you can watch it at half speed.